In this video, we're going to talk about a new type of graph that kind of looks like a table, but it gives us information about the shape of the data. And this type of graph is called a stem plot. Stem plots are specifically used with discrete quantitative data. And remember that discrete data is countable data. 1, 2, 3, 4. Things I can count on my fingers. To make a stem plot, we take our numbers and we split them into two pieces, called a leaf and a stem. The leaf is the last digit in your number. The stem are all the other digits in the number, the leading digits. And we have an example off to the right. Let's go ahead and do that. You'll notice the very first number I encounter in my table is a single digit number. I can't cut that in half the same way I can with 15. When you encounter a single digit number, you use a stem of 0. And that's because I learned at some point when I have whole numbers, I'm allowed to stick a leading digit in front, and that doesn't change the value. But if I have a 1 and I stick a 0 behind, that changes it to a 10. So if I want to make a 1 a 2-digit number, I have to put the leading 0 in front to keep the same value. Let's go ahead and do this for the data in the table. So that's going to become a 0, 1, 1, 5, 0, 7, 2, 4, 3, 1, all the way down the table. What we are effectively doing is then taking those stems and leaves and grouping them by stems. So we're going to make a stem and leaf chart. Stems on the left, leaves on the right. You'll notice the leaves part is longer, the stem part is short. And I need to have enough rows in my table to account for the different stems in my data. And to figure that out, I look at the smallest and largest data values. And I see that my smallest is 0, 1, my largest is 4, 9. Meaning I need stems that go from 0 all the way up to 4. So my stem rows are 0, 1, 2, 3, 4. And then I'm going to go through my data and put the leaves in the appropriate row with their matching stem. And when I do that, I need to list them from smallest to largest. You should include duplicate leaves because we want to make sure that every single data value we collected is visible here in the table. So include duplicates. I'm going to do this similar to how I made my frequency table. I'm going to cross values off as I add them to my table. So I'm going to start with all of the numbers with a stem of 0. So I see a 1, a 7, and a 9. I think that those are all of my 0 stems. So 1, 7, 9. And you'll notice I left a space in between each number, and the numbers are approximately evenly spaced. And we want to do that to make sure that the length of the leaf has meaning. Let's go ahead and keep building. So our next stem, we're going to do all the ones with a leading digit of 1. So I've got a 15, a 12, a 17, and a 16. So I need to do those in order. So 12, and then 15, 16, 17. And that should be the 4 stems with 1. And then I repeat. Now I'm looking for all of the numbers that have a stem of 2. So 4, 5, 6, 7 should be all of them. 4, 5, 6, whoops, 6, and 7. Now we're going to move on to the 3s. 1, 2, 3, 4, 5. So I should have 5. The smallest is 30. I see 2 31s. And then a 35 and a 36. All that should be left now are my 40s. So 42, 41, 49, and 43. So listing those in order, it's going to be 1, 2, 3, 9. And I'm going to double check. I know that this table has 20 values because it's a 4 by 5. I'm going to make sure they all showed up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's a good sign. I probably caught them all. And then the last thing we need to do is we need to make a key so that when I give people just the stem and leaf plot, they know how to interpret that. So up here in the corner, I'm going to make a key, and I'm going to indicate that when somebody sees 3-4, that equals the number 34. The reason stem plots are nice is I don't need any technology to make these graphs, but I can very quickly get a visual on what the shape of the data is, and I don't have to do a lot of forethought in terms of grouping. They're automatically grouped by common stem. So these can be built a lot faster than frequency distributions, and they can be faster than some of the other graphs we're going to talk about, like histograms, later in this week. All right, if you have any questions on Stemplots, you can catch me during office hours or send me an email. Otherwise, I will see you in our next video.